Okay, so in this first Newton's laws review question, we're looking at a sled with a small child placed on top, being pulled by two people with forces of 55 newtons at angles 35 degrees from the horizontal, and a friction force by the snow of 57 newtons. So we're given the mass of the child and the mass of the sled, which we need to combine later, and the total forces are on the sled. And at the instance shown, we're told the sled is moving at a speed of 0.5 meters per second, and we want to know how fast the sled will be moving after it's travelled a distance of 3 meters. So in this particular case, what we first want to do is solve for the net force that is parallel to the surface, assuming that, that these forces, even though they look like small angles, I'm going to assume that again that these are the components parallel to the surface. So if we think about a free body diagram for the child, we could think of having two forces that are equivalent to 55 newtons in the times the cosine of that 35 degrees pointing in this direction, and then a friction force is smaller. There's a friction force here of 57 newtons. So these two are going to be the x components of these 55 newton forces. So these will be 55 newtons times the cosine of 35 degrees. Both of them are of the adults are pulling with the same size force and then same direction relative to the horizontal, and then this friction force is 57 newtons in the opposite direction of the motion. So if we wanted to find, and I'm going to assume then that there's the vertical forces on the child are summed here. The normal force by the snow is cancelled and balanced by the weight force by both the child and the sled. So the F net in this case would be 2 times 55 newtons times the cosine of 35 degrees minus the 57 newtons by the friction. And this works out to be 33.1 newtons. So that's going to be in the negative x direction. So again, here we're starting from magnitudes. So I actually made, in this particular case, I made, I guess I could correct this, but I made the negative x direction actually the positive direction, but you could again label this as negative 2 times 55 times the cosine 35 plus the 57. You would end up though with a net magnitude of 33.1 either way. So I'm sort of solving here with thinking that left is negative, or left is positive, just to keep moving with positive numbers. And then to solve for the acceleration, we divide the net force by the mass, and we're going to have to consider the total mass of the sled and the child. So this will be 19 kgs plus the 3.7, and this gives an acceleration of 1.46 meters per second squared. So now that we know the A, we're trying to figure out how fast the sled and child will be moving. Assuming that this is a constant acceleration, we can then apply constant acceleration kinematics in one dimension. And we want to know how fast the sled will be moving after a certain distance, so we have no time. And so I'm going to solve for Vf. So I know Vf squared is equal to Vi squared plus 2a delta x. And assuming everything to the left is positive, just so I can keep with positive numbers, my final speed would be the initial speed is 0.5 meters per second squared plus 2 times the acceleration of 1.46 meters per second squared times the distance, again converting all of these numbers from negatives to positives so I can make things a little easier to do. The final velocity here would be 3 meters per second, and in this case, again, it would of course be, if we're thinking about the velocity, would be negative 3 meters per second. The magnitude of that velocity would be just a positive. The absolute value would be 3 meters per second. Let's try to see if it's the correct answer. So yeah, just to note that I've sort of, I guess this is technically the negative x, but since I made all these numbers, made sort of left positive, then I end up with this positive answer, which is not unusual to work with, choosing, making a choice to work with positive numbers rather than negative numbers.